Alright, so let's look at the first three problems. We decided that for number one, these two marks of congruency, that's conveying that the sides are congruent. So what is the length of this other leg? 6. So you have two sides of this right triangle, and you need the third. What theorem do you need to use to determine the third side of a right triangle? Pythagorean's theorem. So we've got c squared is equal to a squared plus b squared. Because it is a right triangle, I know that it equals. Remember we were talking about how if it's acute or obtuse, then c squared could be greater than or less than. So because it is a right triangle, I know that it's equal. We're searching for what side length? It's the value of c, or Caroline, the what? The hypotenuse. And we know that the length of the hypotenuse is represented by c in this equation, in this theorem. So I'm just going to leave it as that. Just leave it as c squared is equal to, we have 6 and 6 for our two side lengths. 6 squared plus 6 squared is 72. So what do I need to do on both sides of the equation to determine the value of c?
Take the square root.
Take square root. So I'll do that in a different color. You got square root and square root. When you simplify that, you should get that c is equal to 6 square roots of 2. Someone second that for me? Awesome. Let's move on to the next one. Now for this triangle, we know that it's right as well. However, we are given information about the angles. And so it says that this angle is congruent to that angle. Then we can use the converse of the base angle theorem. And so, yes, it's a right triangle, but what else do we know about this triangle? It's isosceles. So what is the length of this side here? 10. So again, we just use the converse of the base angle theorem. These facts, if your legs are congruent, then your base angles are congruent, or the other way around, if your base angles are congruent, if your legs are congruent, that goes hand in hand every single time. You can't have one without the other. So if your base angles are congruent, it's isosceles, period. And then vice versa. If it's isosceles, your base angles are congruent. So it'll always go hand in hand. So on this triangle, number 2, what are we missing? The hypotenuse once again. So it's going to be an extremely similar problem. So we're going to have c squared is equal to a squared plus b squared, because I know it is a right triangle. I know that these two values equal each other. And so we're missing c. We don't know the length of the hypotenuse. However, the legs are 10 each. So we're going to get that c squared is equal to what? 200. And then what do I need to do on both sides?
Take the square root.
The square root. When it's all said and done, you should get that the length of the hypotenuse, c, in this value, in this one is 10 square root of 2. Okay? For this one, number 3, what is this angle measurements? What is that angle's measurement? It's 45 degrees. We use the triangle sum theorem. It said that because the three angles of these triangles have to be 180 degrees, we have 90 and 45. What's left over is 45. So we can see that's what's true about the base angles of this triangle. They're congruent. Therefore, what else do we know about this triangle? It's isosceles. The legs are congruent. So for this, we only have one side length of this right triangle. We only have one side length. However, because we know that these are congruent, if I labeled this as x, that's what we're searching for, then what is the other leg? X also. So we have done problems like this before. We've done these problems. So there's really only one variable. There's only one unknown. Because once you find one of them, you have both of them. So we're going to use Pythagorean's theorem once again with right triangles. So we know that the hypotenuse is 3 square root 2. And we need to square that value. And then we don't know either one of our legs, but we do know that they're congruent, so we're going to use x to represent both of them. On the right-hand side of the equation, what's x squared plus x squared? You now have 2 of them. Okay, so it's 2x squared. for this, 3 square roots of 2, quantity squared. We're going to do a little bit of scratch work. So this is just somewhere in your piece of paper you are writing this. So what does it mean to square a value?
Multiply by itself.
Multiply it to itself. So expand that. Write it out. I'm multiplying the value 3 squared is 2 to itself. Then once you have it written out like this, just follow the rules that we've talked about in previous classes. You multiply the numbers that are on the outside, those coefficients. So 3 times 3 is 9. Then you draw your radical symbol. Now we need to multiply the numbers that are inside the radical, your radicand. 2 times 2 is what? 4. So that reads 9 square root 4. Or 9 times the square root of 4. Well, let's simplify this. What is the square root of 4? It's just 2. So this value squared is really just what? It's just 18. Okay, so this is all the side work for that. So, but 3 squared is 2. Quantity squared is just 18. Alright, so on the right-hand side, we combine like terms. We have 2 of those x squareds now. So what are we going to do to keep solving? What do we first need to do now? Divide by 2. You must get x squared by itself before you start taking the square root. So I got to get that 2 out of there. Do the inverse operation, which is division. So now I have 9 is x squared. What are we going to do? Take square root on both sides, and the square root of 9 is what? Is 3. Alright, so we got 3 is equal to x. But remember, x was representing the length of the legs. I want you to look at all 3 of these problems and tell me if you can find, or tell me if you can see, a pattern between the length of the legs compared to the length of the hypotenuse. So look at this one first. Then see if something similar is happening in this one. And then confirm it on the third. You're not looking for patterns like, well, 6 minus 10 is negative 4. No, that doesn't work. You're not comparing those values. I'm asking you to look at the length of the leg and how is that compared to the hypotenuse. You've got like a minute just to think about it, look at it. Some of you have already got it, and that's fantastic. And so this is what we're going to do. This is one of our special right triangles. 45, 45, 90 degrees. You see this triangle all the time because if you have a square, if you have a square, which squares are all over the place in this world, especially in like architecture and different designs and so on and so forth. Well, if you have one of its diagonals drawn in, it's now split up into 2 45, 45, 90 triangles. So you'll see them everywhere. They're all over the place. What we're going to investigate is, well, since it's a 45, 45, 90, the legs are opposite the 45-degree angles. So here's the 45-degree angle. The legs are opposite. There's a leg, there's a leg. And so we're going to label the side opposite the 45 is a leg. The side opposite the 45-degree angle, it is a leg. What's opposite the 90? It's always the hypotenuse. We need to be writing this down. This is the whole part where the warm-up leads into notes. So we used Pythagorean's theorem to solve for these missing side lengths. However, there is a pattern, there is a easier way to solve these types of problems. So who found the relationship? Well, how is the leg, how is the length of each leg, how is that related to the hypotenuse's length with these triangles, these 45, 45, 90? Shabelle?
The coefficient of the hypotenuse is the same as the measure of the leg.
Okay. Mathematically, how would you get from a length of the leg? So let's say that it was we'll just use the variable L's. L stands for leg. Well, that means that this would be L, because that's that length. So how would you represent the length of the hypotenuse then? You're taking L, the length of the leg, and you're multiplying it by the square root of 2. This is how it'll always work in 45, 45, 90 triangles. Whatever the length of the leg is, it does not matter what it is. Whatever that length of the leg is, the hypotenuse will always be, whatever that value is, times the square root of 2. Period. So, now that we know this pattern, these problems can be done very, very, very quickly. And so you do not have to write this down. You do not have to write this down. But on the next quiz and the next test, you're going to have problems like this. And so I'll give you a triangle. And somehow I will convey to you that it's a 45, 45, 90 triangle. I could do it like this and just tell you that this is a right isosceles, or I could tell you that it's a right triangle with base angles that are congruent, or I could tell you that it's a right triangle with one of the acute angles being 45. Somehow you'll be able to determine and conclude that this is a 45, 45, 90 triangle. I will do that somehow. I'll just put 45 degrees in there. And then I'll say that this is 4 centimeters or something like that. Determine the other two side lengths. Well, if you remember about 45, 45, 90 triangles, well, these are your two legs, and this is your hypotenuse. That's opposite these angles. And the pattern that is always follows is your legs will be congruent to one another. They'll have the same length, and to get to your hypotenuse, you just multiply whatever that value is times the square root of 2. So for this problem, I gave you one of the legs. So this one's 4 units long, or 4 centimeters. That means this one's 4 centimeters. And what's my hypotenuse? 4 square roots of 2. So very easy. 4 square roots of 2. And you're done. Move on to the next problem on the quiz or the test.